Okay, in this video, we're gonna go over some basics on the math team topics for this month. Let's start with event 1, ratios and proportions, or whatever this is, variation. I'm gonna go over the tryout problem, and because this is a pretty basic one right here. Okay, so number 1. So you have to first start by writing the correct equation. P varies jointly, that means multiply together with F and L, so P equals a constant. Remember, every equation's got to have a constant of proportionality, jointly with F and L, and then inversely as the square of X. Inversely means divided by, yeah? And what's going to happen is if F increases by 20%, L increases by 30%, and X decreases by 33 1/3%, by what percent does P change? And indicate whether it's an increase or a decrease. Now we could actually do this problem by plugging in numbers, but I am not going to plug in numbers. Okay? So this is the way I do it. So I say P1, the initial amount, is going to be equal to this. Now, what happens to P after the changes take place? Well, here's your constant that doesn't change. Now, F increases by 20%, so the new F is going to be what? F plus 0.2 of F, which is 1.2 F, which is 6/5 F. And since we don't have a calculator, write it as fractions, yeah? And what happens to L? L decreases by 30%. So this is going to become 7/10 L, right? It decreased by 30%. And X decreases by 33 1/3%, so that's going to be 2/3 X, and the whole thing gets squared. So what you do is, this is equal to P1, which is the original thing, but then the changes take effect, so it's going to be 6/5 times 7/10 over 2/3 squared, which is actually 4/9. So that's the fraction of the original amount that you have after the changes take place. So if we simplify this, this is P1 times, what do we got? Can we do any simplifying? 6, 3, 2 goes into that 3 times, 2 goes into that 5 times. So that's 21 over 25 times 9/4, which is equal to P1 times 189 over 100. And that's good, because if the denominator is 100, it's easy to figure out a percent change. So P2 is that of P1, which means it was an increase of 89%, right? So increase 89%. Now a lot of the problems though, the numbers don't cut, like the denominator is not going to be 100, so you got to figure out what the percent change is going to be, which is pretty easy. Okay, so that's all I can think of in event 1. I don't think there's any surprises in that event. Next one we're gonna do, let's do it in order of difficulty. Event 2, geometry, similar triangles. Okay, let me just go through the basics of similar triangles. 2 triangles are similar if this angle equals that angle, this angle is equal to that angle, this angle equals that angle. All 3 angles of one triangle are congruent to all 3 angles of another. And of course you know that the corresponding sides will be in proportion, yeah? So A over D is equal to B over E is equal to C over F. And you can do a lot of the basic problems like that, but for the more complicated problems, you want to have some theorems at your fingertips. So let's go over some of those. By the way, these are all in the notes, so you go to the website, click on the notes for meet2, and they should all be there. Okay, now if you have a right triangle, and then you drop this altitude down like this, then there are three similar triangles here, right? You got the big one, the Papa Bear, but then you got the Mama Bear here, and then you got the baby bear over here. All 3 of these triangles are similar, and of course you could set up proportions and get it, but we need to memorize certain things. So if this is A, B, C. And what do we call this? D, E, and F. Okay, make sure you know these things. A squared is equal to E times C. This squared equals that times that. B squared is equal to F times C. So this squared equals that times the whole thing. B squared is equal to E times F. And finally, A times B equals C times D. This last one comes from the area, right? We can compute the area of this triangle as 1/2 A times B. But we can also compute it as 1/2 this times that. So this last one here really doesn't come from similar triangles, it just comes from area. So just make sure you memorize these four right here. And another one, so here's an example. What if you have a right triangle like this, and why don't we make it a 3, 4, 5 right triangle? Drop the altitude down like this. What is that altitude? Well, 3 times 4 equals 5 times x, right? From this fourth one here. Therefore, x is equal to 12 fifths. You can get it really quickly like that. Or now, how do you find y here? Well, 3 squared is equal to y times the whole thing. So that's 5y. So therefore, y equals 9 fifths. See, so if you have these things at your fingertips, it makes life a lot simpler. And then, of course, the angle bisector theorem. If you have an angle of a triangle that's bisected like this, that means you cut it in half, then A over B is equal to C over D. Like in the tryout, something went wrong on that one, but because the numbers came out ugly, but basically you have to use this like 3 times, yeah? So, let's do an example. So if you have a triangle, let's say that this angle gets bisected like this, and then you have to find, let's do a right triangle. You have a right triangle, let's say it's 3, 4, 5, okay? You bisect one of these angles like this. So bisect the angle. How do you compute these two things here? Well, call this one x, and this would be 4 minus x, and then you can apply the angle bisector theorem. This over this equals that over that. So 5 over 4 minus x is equal to 3 over x. Cross multiply, 5x equal 12 minus 3x. 8x is equal to 12, therefore x equals 12 over 8, which can be reduced to 3 halves. So that means this would be 3 halves, and that would be 5 halves. And then you might need to use that in another problem like that, yeah? I mean, another part of the problem. So make sure you know these things. Now there's another theorem dealing with the angle bisector, but I'm not going to mention it on the video just in case if this gets into enemy hands. Look at the notes. Okay, event 3, this is probably the easiest event in the whole year, solving linear equations. So I'm just going to do the tryout problem, just to make sure. So first step, multiply out everything. 3m squared y minus 3m squared plus 2y plus 2 is equal to 5my plus m. And it says solve for y. So the first step, put all the y's on one side. So here are the things with the y terms. Let's put them all on the left. So you got 3m squared y plus 2y minus 5m is equal to, and throw everything else on the other side, 3m squared plus m minus 2. Okay? Factor out the y equals 3m squared minus, something's wrong here. There's a y here, full, minus 5m plus 2 is equal to 3m squared plus m minus 2. Y equals, and then simply divide, 3m squared plus m minus 2 all over 3m squared minus 5m plus 2. Now, this is the answer, but however, you might be able to simplify it. So always make sure you check to see if you can simplify it. So if I factor the top, you get 3m m 2 1 plus minus. The denominator, 3m, m, 2 and 1, minus, minus. Yeah, so these cancel out, so your final answer is m plus 1 over m minus 1. Especially when you have variables, always double check to make sure if you can simplify it or not. Okay. And another video I had the logic. Yeah, for those of you who never learned logic before, make sure you watch that video because I teach you the nuts and bolts of logic. You can also have logic puzzles, but I think we all know how to do logic puzzles. So basically that video is just the nuts and bolts of logic, like truth tables and statements that are logically equivalent and how to deduce valid conclusions from arguments and things like that. Okay, and then I'm going to do event 6 now, solving inequalities and absolute value. Okay, first, the basics. How do you solve inequalities? Okay, let me give you an example. How about something like this? X squared plus 2 is less than 3x. Okay. To solve any inequality, first step, make one side 0. X squared minus 3x plus 2 is less than 0. And then you factor this side. X minus 1, x minus 2. Once the left side is factored, you make a number line. Okay? Put the zeros on the number line. Both of these will not be part of the solution because it's just less than 0. And then test. You have 3 regions to test. Think of a number bigger than 2, like 3. Plug it in. 3 minus 1 is positive. 3 minus 2 is positive. Positive times positive is positive. And then you can keep testing like this, like pick a number between here. 1.5. 1.5 minus 1, positive. 1.5 minus 2 is negative. Positive times negative is negative. Or you can use the pattern. If you have an odd power on the factor, then it's going to change sign. And if you have an even power, it stays the same. So 1 comes from this factor here, which has an odd power. So that means if this is minus, it's going to change sign. It's going to become plus. And we're looking for less than 0, so we shade in the minus ones. So the answer is 1 is less than x is less than 2. Or you can write your answer in interval notation like that. Okay, so the key to solving inequalities is you got to factor. Make one side 0 and factor. Now, assuming that you can factor it, okay, let's look at something like this. Well, let's put some powers. X plus 3, x plus 1, x minus 2. Let's put an even power on one of these. Let's say that one. In fact, okay, let's do that. Greater than or equal to 0. Okay, so once you have it all factored like this, number line, put the zeros on the number line, and whatever makes it the denominator 0 also. Negative 1 is not going to be part of the solution because it's the denominator, but negative 3 and 2 are. So I always like to test this one first because when you plug in a number bigger than 2, you get positive, positive, positive. Everything's positive, so it's positive. Okay? And then 2 came from this factor, odd power, so it's going to change sign. Negative 1 came from this factor, even power, so stay the same. Negative 3 came from that factor, odd power, so it's going to change. And we're going to shade in everything greater than or equal to 0, so all the plus ones. So it's going to be like this. And so we got x is less than or equal to negative 3, or x is greater than or equal to 2. And you always have to use the proper words, either or and in between now. Okay. So solving inequalities is pretty straightforward. Make one side 0, factor the other side, and then make a number line and test. Okay, but what happens when you have absolute values now? This is a whole nother animal. Now, if you have absolute value of x is equal to, say, a, where a is some real number, then that means x equals negative a or x equals a. I believe this is all in the notes. If the absolute value of x is less than a, that means negative a is less than x is less than a. That means x is in between negative a and a. And if absolute value of x is greater than a, that means x is less than negative a or x is greater than a. And of course, this inequality, if you need to split it up, this actually means negative a is less than x and x is less than a. So that means you need to know the difference between and or now. And means intersection, or means union. Okay, so let's look at a problem. Okay, so let's say you have something like this. Absolute value of x minus 2 is greater than 3x plus 1. How would you solve this? Well, doesn't this look like this one right here, this third one? It fits that form, so we just apply it. So, what does this mean? X minus 2 is less than negative a, negative 3x minus 1, or this is greater than a, which is 3x plus 1. So what you do is you solve both of these inequalities, and or it means you take the union of them. Okay, so what do we got here? 4x is less than 1, x is less than 1/4. And then if we solve this one, negative 2x is greater than 3, x is less than negative 3/2. Don't forget when you divide by a negative, you got to change the inequality sign. Okay, so here, this is where you got to think. Or means union. Okay, now if you have a hard time, make a number line. How do you graph x is less than 1/4? Waga! How do you graph x is less than negative 3/2? Waga! What is the union of the two? In other words, if you threw all the numbers less than 1/4 in a box, and then you throw all the numbers less than negative 3/2 in the box, what's in the box? All the numbers that are less than 1/4. So that's your answer. So x is less than 1/4, or you can write negative infinity comma 1/4, not including. If you had the word and in between there, then you would take the intersection. That means where they overlap. So if you had this and that, then the answer would be x is less than negative 3/2. But it's not and, it's or. If you had this case, then it would be and. So you have to keep everything straight. Now, the definition of absolute value. This is the definition of absolute value. The absolute value of x is equal to x when x is greater than or equal to 0, negative x when x is less than 0. So if the inside is positive, you leave it alone. You don't touch it. If the inside is negative, you negate it. Okay? That's how absolute value works. If the inside is positive, you don't touch it. You leave it alone. If the inside is negative, you negate it. Okay? So, let's do the same problem. Now, this method I'm going to teach you now, you can solve any absolute value problem. Any. Let me just make sure this thing is on. Thank goodness. Otherwise, the last 18 minutes would be for nothing. Woo! Okay, so any absolute value problem, you can use this technique here, the number line method. Okay, what do you put on the number line? Well, there's only one absolute value here, so you put down the 0 of that absolute value, which is 2. You don't put down negative 1/3 because there's no absolute value on it. If you had an absolute value on it, then you would also put negative 1/3 there, but it's not. Okay, now, is 2 part of the solution? Well, if you plug it in, you get 0 is greater than 7, which is false, so therefore that's not part of the solution. Okay, now, think of a number bigger than 2, like 3. 3 minus 2, the inside of the absolute value is positive, so you leave it alone. This doesn't change because there's no absolute value on it. Think of a number smaller than 2, like 1 or 0. 1 minus 2 is negative, so if the inside is negative, you negate it. And again, we don't touch that because there's no absolute value on it. Solve this inequality. So this is negative 2x is greater than 3. X is less than negative 3/2. So this inequality that we wrote here only applies on this interval here. So how do you graph x is less than negative 3/2 on this interval right here? You can't, because negative 3/2 is over here and it's going to be to the left. So there's nothing there. Okay, now solve this inequality. Negative 4x is greater than negative 1, so x is less than 1/4. How do you graph x is less than 1/4 only on this interval? Well, 1/4 is here, and then x is less than that will be everything to the left. And then you just look at your number line, and that's your answer. So the answer would be x is less than 1/4. And I believe that was the same answer there. Okay. Now, last thing for this event, I'm going to do the tryout problem. I'm going to show you two ways of doing it. Okay, so solve this inequality x minus 4, 3x plus 2. Okay, so the method I just showed you, this is what you would do. You make a number line, you put 4 and negative 2/3 on the number line. Is negative 2/3 part of the solution? Well, let's see. If you plug in, you get negative 4 and 2/3. No, but absolute value, it's a positive 4 and 2/3 is less than 0. I think that's false. Plug in 4. 0 is less than 14. That's true. Okay, think of a number bigger than 4. 5. 5 minus 4 is positive. But whatever we plug 15 plus 2 is positive. They're both positive, so you leave it alone, and you leave it alone. Solve that. Negative 2x is less than 6. X is greater than negative 3. How do you graph x is greater than negative 3 only on this interval? Well, it would be the whole thing, right? Because negative 3 is here, and you're going all the way across. Okay, think of a number between here, like 0. 0 minus 4 is negative, so you negate it. 0 plus 2 is positive, so you leave it alone. And solve it. Negative 4x is less than negative 2. X is greater than 1/2. How do you graph x is greater than 1/2 only on this interval? Well, you put 1/2 on the number line, and you go to the right, to the right. And finally, think of a number smaller than negative 2/3, like negative 1. Well, negative 1 minus 4 is negative. Negative 3 plus 2 is also negative, so you're going to negate them both. So negate this one, and negate that one. Solve it, so you get 2x is less than negative 6. X is greater than negative 3. That's not correct. X is less than negative 3, fool. Anyway, how do you graph x is less than negative 3 only on this interval? Well, you put negative 3 there, and you're going to the left, and whatever's on your number line, that's your answer. So the answer is going to be x is less than negative 3, or x is greater than 1/2. And that's how you solve it. However, sometimes we can use a shortcut. Not all the time. So whenever you see this case, if the absolute, you have the absolute value of something either less than or greater than the absolute value of something else, whenever you see something like this, square both sides. And the reason you can do that is because both sides are non-negative because they have absolute value on it. Because if you didn't have the absolute value on it, you wouldn't, well, you could square both sides, but then you have to check your answers. But how the heck do you check answers when there's like an infinite number of solutions, right? So, you only can do it when both sides are non-negative. So in this case, they are. So you square both sides, and then of course the absolute values disappear because when you square something, it's going to be positive anyway. And then you make one side 0, like this. Now, if you wanted to, you could multiply it all out. But then look, this is like a difference of squares. A squared minus b squared. You can factor that as a plus b times a minus b. So if this is a and this is b, a plus b would be 4x minus 2. Did I do that correctly? Yeah, and then what is a minus b? Negative 2x minus 6. Factor out the 2 here. Factor out a negative 2 there. And I'm going to divide both sides by negative 4. Now, this is just other stuff you don't have to do. But remember, when you divide by a negative, now it's going to be greater than 0. And then now, look, you just got a simple inequality. You put negative 3, 1/2. See, when I see this, I'm thinking of a parabola that opens upward, right? If you draw the graph, and so it's going to be above, below, above. So you know it's going to be plus, minus, plus. Or you can just plug in numbers to test. And we're looking for greater than 0, so do, same answer, right? So whenever you see the situation, absolute value of gorilla is either less than or greater than the absolute value of banana, square both sides, and then you have a difference of squares. Okay, and then the last event I'm going to talk about is trigonometry. I'm just going through the basics. Now, of course, you have to be able to work with degrees and radians, and you got to know all your identities and trig values. So, solve for x, where x is between 0 and 2 pi Now, if they tell you to give your answer in radians, your answer has to be in radians now. If they say theta is between 0 and 360 degrees, then you better give your answer in degrees. And make sure you give your answer in the domain specified now. Okay? So let's start off easy. 4 cosine squared x equals 3. So cosine squared x equals 3/4. Square root both sides. Cosine x equals plus or minus. Don't forget the plus or minus now. Root 3/2. And notice that since you don't have calculator, it's got to be values you know. So where on the unit circle is cosine plus or minus root 3/2? That's the pi/6 family. So pi/6, 5 pi/6, 7 pi/6, and 11 pi/6. Okay, too easy. Let's do one where you got to actually use identities. How about sine 2x equals cosine x? So applying the identity here, 2 sine x cosine x equal cosine x. Should I cancel cosine x for both sides? Don't you dare. You lose solutions. You just lost 2 solutions by doing that. So make one side 0. Factor out the cosine x. Set each factor equal to 0, so cosine x equals 0, or sine x equals 1/2, and these are all numbers we're supposed to know. So where is cosine x equal to 0? Pi/2 and 3 pi/2. Where is sine x equal to 1/2? Boom! So that would be pi/6 and 5 pi/6. Woo! And then we're done. Okay, let's cover something like this. How about this? Tangent 3x equals 1. Think of this as just a simple angle, like tangent theta. Tangent of what angle? So you can do this when this is a number that you're supposed to know, a special number. So tangent of what angle is 1? That would be pi/4 and 5 pi/4. However, since the variable is 3x, you have to go 3 times around. So what you have to do is add 2 pi to each of these. So that would be 13 pi/4. And then you got to go 1 more time around, so add another 2 pi to each of these, which would be 17 pi/4 and 21 pi/4. And then to solve for x, divide every answer by 3. And that's why you have to go 3 times around, because you're going to be dividing by 3. So you got to watch for that when you have the multiple angle. And then of course, don't forget to reduce. Like a lot of people over here, they put 9 pi/12, but that can be reduced to 3 pi/4. All answers have to be reduced. Okay, and those are the basics right there. This event also includes graphing now, so you have to know your 6 graphs now. Because I remember a question a couple years ago, they asked you like where are the asymptotes here. In fact, what the heck, why don't we just do one? Y equal 2 secant pi/4 x minus 1 plus 3. What are the vertical asymptotes of this graph? Well, one way is you can just draw the graph. Okay, so 1, 2, 3, 4. So draw the base graph. So here's one period, -1, -1. Cosine looks like this, right? So secant looks like this. Whenever it touches the x-axis, you're going to have a vertical asymptote. That's because the reciprocal of 0 is undefined. And then over here, the reciprocal of 1 is 1. The reciprocal of fractions gets bigger, so the graph is going to hump up like that. And then on this side, it's going to hump down like that. And then over here, it's going to hump up like that. So that's one period of secant x. But then now, you got to do things to it. What does this do to the graph? It multiplies the x coordinates by 4 over pi. So if you multiply this by 4 over pi, this becomes 8. So that means this is 4, this is 2, and this is 6. And then, what does this do to the graph? It shifts it 1 to the right. So instead of the asymptote being at x equal 2, it's going to be at x equal 3. And then instead of 6, it's going to be at 7. And then of course, once you shift everything over, notice that it's 4 apart. It's going to be 11, ... like that, right? Now, what about this? Well, multiplying the y coordinates by 2 just stretches it vertically by a factor of 2. So that's not really going to change the vertical asymptote. And this shifts everything up 3 units. That also does not affect the vertical asymptote. So these are the vertical asymptotes here. Now, in this event, they're not going to have an infinite number of answers. So they'll probably ask you, find all the vertical asymptotes between x equals 0 and 20, say. Or something. They'll give you a range. So then you would say x equals 3, 7, 11, 15, 19. And you have to have x equal because a vertical asymptote is a line, right? So you have to give the equation of a line. So that's the basics of trigonometry right there. So you got to be able to solve equations. And also when you solve equations, always make sure the denominator cannot be 0 now, because tangent, cotangent, secant, and cosecant are fractions. So you got to make sure the denominator is not 0. So always double check your answers. Like here, something like this. This is an easy one. This would be an A problem. Solve this equation. So solve for x, solve for theta, where theta is between 0 and 360 degrees. Secant theta equal tangent theta. Okay, well, change everything to sine and cosine. Multiply through by cosine, so you get 1 equals sine theta. So therefore, theta equal 90 degrees. Write that on the answer line. Don't be ridiculous, because, come on, 90 degrees makes tangent and secant undefined. So there is no solution. So on that, you would write no solution. If they were to ask you, what is the solution set? Then you would write this, empty set. Anyway, so always be careful about that. Okay, so that's it. Hopefully we're on our way. Everybody needs to kick it up a notch, this meet.